Welcome to our video tutorial involving ellipses. We're going to look at two problems. First, this problem, where we're given an equation and we want to sketch the ellipse in its entirety. Second, we will be given the picture of an ellipse and we will try to come up with its equation. So first thing that we want to do is gather the variables on one side. We will add the 100x to both sides, group the x's together. We will also subtract the 72y from both sides, group the y's together, and then we can leave the number off on the other side. Now we factor out the number attached to each of the variable terms from their respective variables. So for instance, we're factoring out the 25 from the x's, and we're factoring out the 4 from the y's. Now once we have done that, we complete the square accordingly. So over here, we have to pair up a positive 2 with the x in the complete the square process. 2 squared is 4. Be mindful that what we have really put into this equation is a plus 100, so we have to really subtract 100. Then with the y terms, what's going to go in the parentheses when we complete the square would be a minus 9, cutting the negative 18 in half. 9 squared is 81, but we have to be careful and be mindful of the fact that what we really have thrown in here is a plus 324, so we really have to subtract off 324. Now 100 and 324 combined would be a minus 424, and then we want to get the number over on the other side. So we have 25 times the quantity x plus 2 squared plus 4 times the quantity y minus 9 squared is equal to 100. And as we saw in class when we're doing this, we want to divide through by 100 because for an ellipse we need the equation to add up equal to 1. Now as we simplify things accordingly, we get x plus 2, the quantity squared over 4, plus y minus 9, the quantity squared over 25, is equal to 1. Let's highlight that, because that is going to be key in determining our ellipse. Notice the center of our ellipse is going to be at negative 2, 9. Also notice that this is going to be a vertical ellipse because the number under the y squared is larger than the number under the x squared. When determining how much left and right we go, it's the square root of the number in the bottom. In this case, that'll be 2. When determining how much up and down it goes, it'll be the square root of the denominator for the y term. In this case, that would be 5. So when we go to draw this ellipse, and we can just do a rough sketch, we know it's going to be a vertical ellipse, so we can draw it more elongated vertically. We know it's going to be a vertical ellipse, so we can draw it more elongated vertically. We know where the center point of our ellipse is. It's going to be at negative 2, 9. Please label it. Now we go up 5 to get this major axis endpoint. That'll be at negative 2, 14. We go down 5 to get the other major axis endpoint at negative 2, 4. Then we're going to go left and right too. So this other point will be at negative 4, 9. The other minor axis endpoint will be at 0, 9. And then we need the focal points. Now to find the focal points, it's kind of like a Pythagorean theorem when we do this. And when we look at the Pythagorean theorem, it's a little bit different in this one. We said a squared is equal to b squared plus c squared. C, of course, being the distance for the focal point. A is the larger of those denominators. A squared is just the denominator itself. B is the smaller one, and C is the focal point. So here we're going to get that c squared is 21, or c would be plus or minus square root of 21. So we have to go up square root of 21 to get to the one focal point. It will be at negative 2, 9 plus radical 21. And we have to go down radical 21 to get to the other focal point it'll be at negative 2 comma 9 minus the square root of 21. This would be our ellipse. It has all of the key features labeled. Everything is simplified accordingly. We would be good to go. But now, what if we were given a picture and asked to determine the equation? So the first thing we could do here is quickly identify the center point. It will be at negative 2 comma 5 because it has the x value from that and the y value from that. We could also quickly identify how far we are going to get to the endpoints of the axes. In this case, the green label is 4. In the other case here, what I'll label as red, that's going to be 2. We notice that this is a horizontal ellipse. It's going to be x plus 2 squared divided by something because the center point has an x value of negative 2, plus y minus 5, the quantity squared, divided by something because the y center point is at 5. We know an ellipse is always equal to 1 when we add things up. Horizontally it's going 4, so this denominator under x will be 16. Vertically it's going 2, so the denominator under the y will be 4. And that's actually our equation. X plus 2, the quantity squared, all over 16, plus y minus 5, the quantity squared, all over 4, is equal to 1. If we wanted to determine the focal points, remember for focal points we've said that a squared is equal to b squared plus c squared. A is the larger, and a squared is actually 16. B is the smaller, b squared is actually 4. So we would have 12 is c squared, or c would be plus or minus the square root of 12. Please simplify, so c would be plus or minus 2 radical 2. So if we really wanted the focal points on this one of our focal points would be at negative 2 plus 2 radical 2 comma 5. And the other focal point would have been at negative 2 minus 2 radical 2 comma 5. The focal points are always in the same direction as the major axis. And really, once we get the hang of that, that's the basics for an ellipse.